Your AI built this app. An attacker is already inside. Here is what happens next. Not next month. Not after you scale. Not after you hire a security team. Right now. Because the new generation of apps is being shipped faster than anyone can inspect them. Cursor wrote the backend. Lovable generated the dashboard. Bolt connected the APIs. Riplet agent deployed it. V0 built the interface. Claude Code filled in the missing pieces. The founder tested a few features. The app worked. The customer paid. Production went live. And almost nobody involved actually read every line of code. Almost nobody understood every dependency. Almost nobody checked every secret, every permission, every integration. The application shipped. The attack surface shipped with it. And now the timeline begins. Initial access. Every breach starts with a door. The interesting part is how small that door can be. Maybe it is an exposed API key. An API key is a digital pass that allows software to talk to another service. Maybe the AI accidentally hard-coded a secret. A hard-coded secret is a password or credential embedded directly into the code. Maybe a dependency was prompt injected. Prompt injection means an attacker tricks an AI-powered tool into generating or accepting something it never should have trusted. The founder never sees it. The app launches. The attacker finds it. And then they enter, not with alarms, not with explosions, just a single successful request. One response, one credential, one overlooked permission. From the outside, nothing changes. The login page still works. The dashboard still loads. Revenue still comes in. Customers keep using the product. The attacker is already past the front door, and nobody knows. Enumeration. The next phase is enumeration. Enumeration means learning everything possible about the environment. This is where the attacker stops being a visitor and starts becoming a cartographer. They map everything, every environment variable, every database connection, every cloud resource, every storage bucket, every forgotten test server, every integration that was added at 2 a.m. and never documented. They discover what the founder forgot. They discover what the developers never knew. They discover what the AI generated automatically. The attacker begins reading the business itself. They find payment systems, email providers, customer records, authentication systems, analytics dashboards, cloud accounts, internal tools. The founder sees a startup. The attacker sees a blueprint. In many cases, they now understand the architecture better than the person who built it. Because unlike the founder, they are reading every connection, every permission, every credential, every weakness. Some founders would struggle to answer that question. The attacker would not. They already counted. Persistence. Now comes persistence. Persistence means making sure access survives even if the original entry point is discovered. This is the moment most people misunderstand. They imagine an attacker breaking in once. They imagine fixing the vulnerability. They imagine the story ending there. That is not how the story goes. Because attackers do not want access. They want continued access, so they create new paths, a new IAM user. IAM stands for Identity and Access Management. It controls who can access cloud resources. A new account appears, maybe nobody notices. A serverless function gets modified. A serverless function is a piece of cloud code that runs automatically when triggered. A small change, a hidden call, a secret connection, nothing obvious, nothing visible. An additional SSH key gets added. An SSH key is a digital credential that allows remote access to a server. The original vulnerability could disappear tomorrow. It would not matter. The attacker is no longer dependent on it. The first door was only temporary. They have already built new ones. The founder patches the bug. The attacker logs in anyway. The founder rotates the credential. The attacker remains. The founder celebrates fixing the issue. The attacker watches the celebration happen because they never left. Pause on that question. Not whether you think you would know, whether you actually would. Lateral movement. Then comes lateral movement. Lateral movement means expanding from one system into many others. This is where a small app stops being a small app, because modern software is connected to everything. The application talks to Stripe. Stripe talks to revenue. The application talks to an email provider. The email provider talks to customers. The application talks to Google Workspace. Google Workspace contains contracts, documents, conversations, invoices, roadmaps, and years of company history. One credential becomes another. One integration reveals another. One permission unlocks another. The attacker follows the connections. Not because they are guessing, because the connections already exist. The startup spent years building convenience. The attacker uses that convenience as infrastructure. The founder sees integrations. The attacker sees pathways. The attack expands quietly. A customer database becomes a financial system. A financial system becomes an inbox. An inbox becomes every conversation, every proposal, every client list, every acquisition discussion, every investor update, every internal disagreement, everything. The compromise is no longer technical, it becomes organizational. The attacker is no longer inside an application, the attacker is inside the company. Exfiltration. The final phase is exfiltration. Exfiltration means taking the data out. This is the part people imagine incorrectly. They picture massive downloads, gigabytes disappearing instantly, red warning lights, emergency alerts. That is rarely necessary. Smart attackers move slowly. A little today, a little tomorrow, a little next week. Small chunks, tiny requests, traffic that looks normal, data hidden among legitimate activity. Customer records, financial information, private documents, internal messages, source code. One piece at a time, the information leaves so gradually that it blends into the background. Weeks pass, maybe months. The company continues operating, customers continue paying, founders continue building. Meanwhile, copies of the business are accumulating elsewhere. Not enough at once to trigger concern, just enough over time to reconstruct everything. The attacker does not need urgency. The attacker already won earlier in the timeline. Now they are simply collecting. The most unsettling part, the breach often exists longest during this stage, not because it is sophisticated, because it looks ordinary. Normal traffic, normal requests, normal operations, until one day someone notices something that should not have happened. A customer reports suspicious activity. An account appears somewhere unexpected. Data surfaces where it should never exist, and only then does the investigation begin. Months after the first access, months after the mapping, months after the persistence, months after the movement, months after the extraction, the discovery happens at the end. The compromise happened at the beginning. The code worked. That was never the question. The payment has been processed. The dashboard loaded. The demo impressed investors. The customers signed up. The AI generated thousands of lines in minutes. The application shipped, and somewhere in that speed, visibility disappeared. Nobody reviewed everything. Nobody understood everything. Nobody owned every line. The software went live anyway. The attacker did not need to rush. The attacker did not need luck. The attacker only needed one thing: access. And once they had it, the rest followed naturally. Mapping, persistence, expansion, extraction, a complete timeline, a complete compromise, a complete story. You shipped it in a weekend. They moved in the same night. You still have not noticed.